Hi, Mrs. LaJoy here. Today we are going to talk about polynomials. So the first thing I want to review with you as we start into this discussion of polynomials is exponent laws. So we have a few different exponent laws that we have to follow when we're working with exponents. So the first one has to do with multiplication. So when we are multiplying, we have to add our exponents. So for example, if I have 2 to the power of 3 times 2 to the power of 2, because we're multiplying, we add our exponents. So I end up with 2 to the power of 5, because 3 plus 2 is 5. Now when we're dividing, we have to subtract exponents. So for example, if I have 2 to the power of 3 divided by 2 to the power of 2, I'm going to subtract those exponents. So 3 minus 2 is 1, so my answer is 2 to the power of 1. Or we can just write 2. We don't usually write the exponent 1 because it's kind of redundant. This question could also look like this: 2 to the power of 3 divided by 2 to the power of 2. These two things are the same, right? If we write it with the division sign, or we write it as 2 to the power of 3 over 2 to the power of 2, both of them mean divide. Okay, now the next one is when we have powers. So powers, we are going to multiply the exponents. So when we multiply exponents, for example, if I have 2 to the power of 2 to the power of 3, I've got like two layers of exponents here, so I have to multiply these exponents. So this is going to be 2 to the power of 2 times 3 is 6, so 2 to the power of 6. Okay, the next one is inverse. So inverse is really a negative exponent. When we have a negative exponent, we're going to take the reciprocal. So remember that when we did slope, we had negative reciprocal slopes, and we took the opposite, like we flipped it. So for example, if I have 2 to the power of negative 1, that negative exponent, what this is going to be is I'm going to take this 2 and flip it. Remember that when we have a whole number, there's an imaginary 1 underneath this 2. So I'm going to flip this. I'm going to have 1 over 2, and that's my answer. All right. The last exponent law that I need you to be aware of is when we have 0 exponents. Oops. That looks terrible, but that's all right. 0 exponents. That means they are equal to 1. So this is not the same thing as having a number that has no exponent. For example, you just have 2. Remember that for this, the exponent is really 1, because if we don't write it, it means there's a 1 there. What I'm talking about is if we have a 2 to the power of 0. So 2 to the power of 0 is equal to 1, no matter what it is. If it's 63 to the power of 0, it equals 1. So those are our exponent laws that I need you to be aware of as we get into this unit. Now the next thing that I want to look at with you is simplifying and expanding polynomials. Actually, you know what? We're going to get into some examples, and then we'll come back to looking at simplifying and expanding. because it's kind of building on what we've done before. So let's look at some examples of using exponents. So let's change my color here. So for example, if I have 2m to the power of 4 times 5m to the power of 4. What I'm going to do here, this is still multiplication, right? So I'm going to multiply these two numbers. So 2 times 5 is 10. Now I have to look at my exponents. Because I'm multiplying here, remember the exponent laws say that we have to add our exponents. So 4 plus 4 is 8. So I'm going to have 10m to the power of 8. And that's my answer. All right. Another question. Let's say we have 6k to the power of 2 times k. So again, we have to look at our coefficients. That's the number before the letter. This one here, the second k has a 1 in front of it. So 6 times 1 is just 6. Now our exponents. So k to the power of 2. And this k over here, because we don't have an exponent written, it means that the exponent is 1. So again, we're multiplying, so we have to add our exponents. So 2 plus 1 is 3. So 6k3. Another example, let's look at dividing now. Okay, so when we're dividing, let's take an example like 3r to the power of 3 divided by 2r. So when we work this question out, we have 3 divided by 2. Well, that's kind of messy, but we're going to leave it as that fraction. So we've got 3 over 2. Now what do we do with our exponent? Well, when we're dividing, we have to subtract exponents. So if I have a 3 up here and a 1 on this r on the bottom, that means 3 minus 1. So that means we're going to have r to the power of 2. So 3 over 2, r to the power of 2 is our answer. Another example, let's look at another division. So if we have 7n to the power of 2 over 4n to the power of 3, let's see what we can do here. So 7 divided by 4, again, that's kind of messy, but so we're going to leave it as a fraction. So 7 over 4. Now let's deal with the exponents. I have 2 minus 3. What does that give me? It gives me a negative 1, right? So I've got 7 over 4 n to the power of negative 1. Or, remember back to what I just talked to you about with exponent laws. If I have a negative exponent, I can put it, I can flip that exponent, right? So what I'm going to do is have 7 over 4. And I'm going to put the n down here on the bottom. That's my answer. We'll do another one like that, okay? So if I have, for example, 3b divided by 10b to the power of 3. Again, I'm going to leave this fraction as 3 over 10 because I can't reduce it any further. So 3 over 10. Now with my exponents, I have b divided by b to the power of 3. So that's really like 1 minus 3. Well, 1 minus 3 is going to be negative 2. So my answer here is 3 over 10 b to the power of negative 2. Or I can flip this around and I can say 3 over 10 b squared. All right? So I'm taking it from the top and moving it down to the bottom. just like I did with the purple question over here, with 7 over 4 n. Okay, another example of working with exponents. Let's look at powers. So an example of using powers. So if I have a question that says 3a squared, we close the bracket, and to the power of 3. Okay, what I have to do here is apply this 3 to everything in my bracket. So 3 times 3 is going to be 27. Now I look at my exponents. So I'm going to keep this same variable of a. When I have powers, I have to multiply, right? So 2 times 3 is 6, so that means 27a to the power of 6. I'll do another example with the powers. So let's say we have bracket 7y to the power of 4 squared. Again, we're going to apply this to, oh, my cat just jumped on the table. Just down. I'm going to apply this to the whole bracket. So that is 7 squared. So 7 to the power of 2 is 49. And I'm going to keep the y. And then I have to deal with these exponents here. So if I have a 4 in the bracket and a 2 out of the bracket, I have to multiply. So 4 times 2 is 8. So my answer is 49y to the power of 8. So that takes care of our questions with exponents. I'm going to clear this, and I want to look at some questions with simplifying polynomials. That's the next kind of step, because we're going to apply some of what we've done here in the next part. So if we're looking at polynomials, so simplifying polynomials, you might have a question that looks something like this. So 4 plus 4r minus z plus 3r plus 5z minus 2. So the first thing we want to do when we have a long list of terms here is to combine our like terms. So let's look first. Remember that when we write answers, we want to put our variables in order. So let's rearrange this question here first. So let's put all of my terms that have an r together. So I can write 4r. What else do I have? I've got a 3r here, so plus 3r. That takes care of my r's. Now let's look at my other terms with variables. I've got a negative z, so minus z. Do I have any other z's? Yes, I have this plus 5z, so plus 5z. And then I have my constants. I've got a 4 and a negative 2. So I have plus 4 and then minus 2. So now I've got all my terms in order. It's easier now for me to combine my like terms, right? So I've got these are like terms, these are like terms, and these are like terms. So let's combine those like terms. So 4r plus 3r is going to be 7r. Negative z plus 5z, so that's negative 1 plus 5 is going to be positive 4z. And then I have positive 4 minus 2, so that is plus 2. And that's our answer. So all we did was simplify this polynomial by combining our like terms. You might have some other questions that ask you to expand and simplify. So if you are asked to expand and simplify. So let's look at a question like this. If we have 3 times x plus 2, what we have to do is multiply this 3 times everything inside the bracket. So like I showed you before in class, I like to use my arrows, so I make sure that I multiply everything outside the bracket by everything inside the bracket. So 3 times x is 3x, and 3 times 2 is 6. And that's our answer. We can't go any further than that, so 3x plus 6 is our answer. Let's look at another question that's a little more involved. So if we have a question that says 5 times k minus 1 plus 3 times 2k minus 2. So we need to multiply everything again outside the bracket by everything inside the bracket. So that means I have to do 5 times k is 5k. And 5 times negative 1 is negative 5. Over here, I have 3 times 2k is going to give me positive 6k, and 3 times negative 2 is going to be negative 6. So again, I want to now combine my like terms. That's the last step of this question. So I've got a 5k and a 6k. So 5 plus 6 is 11. So I get 11k. My variables are gone now. I just have a negative 5 and a negative 6. So negative 5 minus 6 is negative 11. That's my answer. That's as far as I can go. So I expanded at the beginning of the question by taking whatever was outside the bracket and multiplying it by everything inside the bracket. And then I simplified by combining my like terms. So we'll look at, let's do 2 more examples. So another example, we have 2 brackets next to each other. So if I have a bracket that looks like this, so I have 2x plus 1 times 3x plus 7. I have to multiply everything inside the first bracket by everything inside the second bracket. So again, I'm going to use the arrows to make sure that I get all of the terms. So if I do 2x times 3x, I get 6x squared. Remember that when I have these two x's, I'm multiplying, so I have to add my exponents, right? This is a 1 and this is a 1, so I get a 2. I added 1 plus 1. Now 2x times 7 is going to be 14x. There's no x on the 7, so I'm just multiplying my numbers and keeping the variable. Now I've got to do the next term, so I'm going to go under the bracket. So 1 times 3x is going to be 3x, so plus 3x. And 1 times 7 is 7, so plus 7. Now I want to combine those like terms. This is the last part of the question. So like terms, remember that we have to have the same base, and if I only have if I have 6x squared and 14x, I can't combine those like terms because they're not the same. One has a base of x squared and the other has a base of just x. So we can't combine them because they're not like terms. So I'm just going to put my 6x squared. There's nothing to combine with that. I can combine these though. 14x plus 3x. So 14 plus 3 is 17. So that means I have plus 17x. And then this term is all by itself here. So 7, so plus 7. And that's our answer. So we expanded by multiplying the two brackets by each other, and we collected our like terms to simplify. All right, next example. So what about if we have one that has a power? So if I have a question that says 3x plus 2 to the power of 2, really, that is the same as 3x plus 2 times 3x plus 2. So you may want to rewrite the question. I prefer to rewrite the question like this. That way I can make sure that I multiply each term in the first bracket by each term in the second bracket. So these things are the same. Okay, so when we solve this one, I'm going to multiply. So again, I'm going to do 3x times 3x. 3 times 3 is 9, and my x times x gives me an x squared. So I have 9x squared. 3x times 2, 3 times 2 is 6, so that means I have plus 6x. Now the next, I'm going to go underneath for the next term. So 2 times 3x gives me plus 6x, and 2 times 2 gives me 4, plus 4. Let's combine our like terms. Again, there is only one term that has the x squared, so I have a 9x squared. I have a plus 6x and a plus 6x, so I can combine those together. 6 plus 6 is 12, so plus 12x. And then I'm left with this 4 over here, so plus 4. And that's our answer. So those are some examples, and there will be similar questions in the work that I assigned to you of using our exponent laws and simplifying and expanding polynomials.